Bismillahirrahmanirrahim. We're still on chapter 4. Now we move to the electrolytic cell, a new subtopic. So what is electrolytic cell or what is electrolysis? Mainly the subtitle. Electrolysis is a process of dissociation or decomposition of electrolyte to produce element using an electric current to force a non-spontaneous chemical reaction. Okay, reaction will take place in electrolytic cell. The mechanism is opposite compared to voltaic cell, because voltaic cell will create electric energy from chemical reaction, but in this cell, in electrolytic cell, it uses electrical energy to force a chemical reaction to happen. Electron flow from anode to cathode through external circuit. The step involved in the electrolytic cell is ion movement toward the electrode and ion discharge at electrode. We have two electrodes. In one electrode, there will be a deposited of the element, and in another electrode, it will become discharged. It will be become thinner. Okay. So this is the electrolytic cell. So we see it is in one container. Both electrodes are dipped in a same electrolyte, which is connected with the electrical power, with the energy supply. Anode is positive. It's different from the voltaic cell, which is negative, and cathode is negative. But it is the same thing happen in anode, which is oxidation, and same thing happen in cathode, which is reduction. In anode, in positive electrode, the anion will move toward it, but in cathode, negative electrode, the positive ion, the cation, will move toward it. Okay. So this show electrolytic cell. We need to have a battery, power supply. We should have electrolyte, the cathode and anode, and the direction of electron flow. Shows the same thing. Oxidation is losing electron. Reduction is gaining electron. Oxidation is losing. Reduction is gaining. Okay. Again, the same thing. Cation move toward cathode. Cation is positive. Ion will move to the negative electrode. Anion, negative ion, will move to the positive electrode, which is anode. Commonly used electrode is inert electrode. Normally platinum and graphite. The electrolyte is a molten salts or aqueous solution of salts. Because this process is famous in production of hydrogen gas and chlorine gas, and also salts, sodium. Sodium solid. Okay, this is the factor that affect electrolysis in a electrolytic cell. First, position of ion in electrochemical series. It is not like in electrolytic cell we have the SRP table, but this one is position of ion in electrochemical series. So you have to remember this series, this position. The second one, types of electrode that we use. The third one is the concentration of electrolytes. This is the relative stability. The one at the top is more stable compared to the one at the bottom. And tendency to discharge. This is for cation, this is for anion. And tendency to discharge is lower to the one at the highest position compared to the one at the lower position. The elements at the species at the bottom position, at the lower position, will have high tendency to be discharged. Lower position will be selectively discharged. Okay, so that is the position of ion in electrochemical series. Okay, the second one is types of electrode that we use. Either we use inert electrode or active electrode. Okay. And the last one, number 3, is also depends on the concentration of electrolytes. Ion with higher concentration will be selectively discharged. Okay. Okay, for electrolytic cell, we need to look at the reaction happen is depends on a cases basis. We have molten sodium chloride, we have aqueous sodium chloride, dilute aqueous sodium chloride, we have concentrated aqueous sodium chloride, we have copper solution. Okay, that one kita akan tengok satu-satu. Okay. For molten sodium chloride in the electrolyte, for molten sodium chloride, you just assume that you take salts without adding water. So when we melt the salts, the only ion have inside the electrolyte is the sodium and chlorine. Okay, sodium ion dengan chloride ion. Okay, this process is a major source in producing pure sodium metal and chlorine gas. So in the molten sodium chloride, it only have sodium plus dengan chloride ion in the electrolyte. So the reaction happen during the electrolysis of this molten sodium chloride is this one. In the anode, anode is the positive electrode. The chloride ion will be attracted to it and will be reduced to chlorine gas. While at the cathode, negative electrode, sodium ion, sodium plus ion, will be reduced to sodium. Okay, sodium lumps or sodium metal. So this is the overall reaction. Molten sodium chloride is very simple because there is no other ion interfere. We don't need to consider the location of ion in the electrolysis table. Okay. This one we use inert electrode because we don't have solid chlorine and we don't have we do have sodium metal, but it is not a metal actually, just like rubber. It is not like a metal. Okay, so that's why we use inert electrode, which is platinum. Okay, so that is for molten sodium chloride. For electrolysis of aqueous sodium chloride in a dilute condition, dilute aqueous sodium chloride, in the electrolyte, we have this ion. We have sodium plus, we have hydrogen from the from the water, we have chlorine, chloride ion, and we have hydroxide ion. So we need to refer to the table. Okay. Again, we still use inert electrode, platinum electrode. In anode, either chloride ion or hydroxide ion will be discharged. So if you refer to the table, OH is less stable compared to chloride ion. Yeah? Hydroxide ion is less stable compared to chloride ion. So OH, hydroxide ion, is selectively discharged at the anode. Yeah? So the reaction, the half cell reaction for hydroxide ion is this one. Yeah? For hydroxide ion, will be reduced, will be oxidized to form 2 water molecule plus 1 oxygen gas plus 4 electron. Okay. In the cathode, at the cathode, we have sodium ion and hydrogen ion. Since hydrogen ion is less stable compared to the sodium ion, hydrogen ion will be selectively discharged at the cathode. So this is the half cell reaction for the hydrogen ion. Yeah, half equation reaction for the hydrogen ion. For hydrogen ion plus 4 electron will be reduced to 2 hydrogen gas. Yeah? And the overall reaction, you just cancel out the electron, then we'll have this. Okay, so that is for dilute aqueous sodium chloride. For concentrated sodium chloride, aqueous sodium chloride, yeah, since hydrogen ion and hydroxide ion concentration is too low, yeah, because this is concentrated sodium chloride, we have more sodium and chloride ion. So chloride ion will be discharged at the anode, but at the cathode, still hydrogen ion will be discharged. So this is the reaction for chloride ion. This is the reaction for hydrogen ion. Okay, and this is the overall reaction. Yeah? For this, you have to you have to remember the half cell on the left and half cell at the cathode. Yeah? Half cell at the anode and half cell at the cathode, together with the overall reaction. Okay, so that is for sodium chloride, concentrated sodium chloride. And this is for copper sulfate solution. Yeah, aqueous copper sulfate. So when we say aqueous, when we call it solution, color molten, it's only copper sulfate. Yeah, copper 2 plus and sulfate 2 minus ion. But for solution, we mix with water. So we have hydrogen and hydroxide ion. We need to consider that species as well. In the electrode, yeah, the electrode used is the carbon electrode. Okay, so at the anode, since hydroxide ion is less stable compared to sulfate ion, yeah, you refer to the table. OH ion will selectively discharge at the anode, yeah, according to this half cell reaction. While at the cathode, we have copper and hydrogen ion. Since copper is less stable compared to the hydrogen ion, so copper is selectively discharged at the cathode. So this is the half cell reaction at the cathode. At the anode, we get the oxygen gas. At the cathode, we get a copper solid. So dekat cathode ni, dia akan lebih tebal, because copper solid will be deposited at the cathode. And this is the overall reaction for this cell. Okay.